So session 2 of AA agent, core building blocks. We are going to discuss core building blocks of an agent. And if you remember the last session, we introduced a warehouse clerk who is responsible for shipping a particular order. Let us say the order ID of that is 4521, right? Now, the goal is she has to ship the order, right? And then while shipping the order, she did not follow a fixed procedure or a script. Dynamically, she has taken the decision. How she has taken the decision? She observed the current state of the particular order and decided that the payment is not done. When the payment is not done, she acted herself to make a call, maybe using a tool or something, whatever the company provided, and then asked the customer to do a payment. And again, after some time, she goes back and see once the customer is made the payment or not, and then the status is changed. When she identified the customer has paid the money or the payment is done successfully, then she went for the next step. The next step, what did she do? She asked the floor people to pick the order, and then finally she shipped that product, handed over the product to a courier guy. By handing over the product to a courier guy, her goal is completed. So there is no fixed script here. She decided based on the current state. Based on the current state, she found out the payment is not done. Once the payment is not done, she identified that, okay, let's call the customer. That's a dynamic way of doing the things, right? Until the goal is finished. That is a human way of working, right? Now, the same goal, if we give to a software, basically what we are saying, we are trying to replace the clerk with a software. But for us to replace the clerk with a software, we need to answer practical questions, no? How that particular software, let us say we call here that particular software as an AI agent. How does that AI agent has the ability to perceive, decide and act? No, because what that clerk has done is perceive, decide and act only, right? She perceived that the payment is not done and then she has taken the decision to make a call to the customer. She acted up, she acted it, she did it, isn't it? But AI agent, when the AI agent replaces that particular clerk, how does it knows? How does it perceive? How does it decide? How does it act? Answer is simple. So earlier you remember PDA, right? Perceive, decide, act. Now you remember few things. Foundational components for all these PDA. Perceive, decide, act. These foundational components are: number one is prompts, number two, tools, number three, memory. If you look at the famous tools like Langcrop, CrewAI, AutoGen, OpenAI agents, SDK, semantic kernels, and all these things, right? Where the many of the people are working, or these are all like well-known names in the agentic AI frameworks, correct? All these things they basically build based on these three foundation components only. Let me repeat, what are those three foundation components? The foundational components are: number one, prompts. Prompt is something that we want to give to the model, no? Because when we talk about a model, an LLM, which is a large language model, is basically it cannot communicate to your database. It cannot connect to your database. That itself does not understand the status of your order. The prompt has to give the information to the LLM, correct? Now the tools. Tools, imagine the tools, some kind of like SDKs or some kind of like functions, no? We write like Java functions, Python function. Since in agentic AI, the AI, most of the, we use the Python as a programming language. We can think of tools as a functions. Simple like Python functions kind of thing, right? Or memory. Memory, the data, whatever the data that we want to provide a particular tool or the context, we should be putting into the memory. Again, memory is two kinds of memory: short-term memory, long-term memory kind of things. We will discuss. Let's go component by component. Now, the first thing is perceive, right? Perceive, decide, 3 act. This is the basic, right? This is the basic, how a AI agent does actions. I mean, goes through phases kind of thing. First, AI agent, it has to go through the perceive, then the decide, then the act, including the human being also. Now, let us discuss about the components. Components of AI agent. Okay. Or I can say core building blocks. Okay. One is what? Prompts. Now, an LLM doesn't see database. It doesn't see emails. LLM, which is a large language model, it is a stateless. Correct? If there is a database, it can't see. Email, it can't see. File system, it can't see. Okay. What it can see? LLM can see text. Text only. This text is put where? In its context window. Okay. LLM can only see the text placed inside its context window. So what does it mean? That means perception is really a prompt engineering problem. The first thing, perception is prompt engineering problem. When an agent observes the world, in this case the world, order, right? The status of the order. What it's actually doing is converting the current state into text and presenting it to the model. So what does it mean? There is a agent, there is an LLM, and it has to, LLM reads the context. A agent has to provide the context to the LLM. Correct? So it observes the world, like how the warehouse clerk has observed the status of the order. Agent also has to do the same. Okay. So what does the agent, support agent while processing the refund request? What are all the things that real world state might be? Let's say refund processing, right? You want to process a refund. Real world status in this case maybe customer email. Who is the customer? The agent wants to understand. Order status, if it is paid or not. If it is not paid, then we don't refund. No. Okay. Shipping status. Okay. It is shipped or not, etc. Right? Customer could have cancelled the order even before the shipping has been arrived. In that case, you don't need to send a person to pick the order, no? So these are all dynamically taken decisions, correct? So if you look at these things, where do you find all these things? In a typical database, correct? Now, does the LLM has the access to to this database? No, it does not have the access to this database. Someone has to tell to the LLM. Okay. Now, imagine you are a customer support agent. Customer message is my order arrived damaged. Okay. Let's say customer message is my order, let's say damaged, right? My order arrived, right? Arrived damaged. Now, what is the order status? It's delivered. Arrived, right? That means the order status is delivered. Order value, let's say some $100 or something. And then what is important thing? Refund policy. If the policy says there is no refund, only replacement, then the replacement is the next action, right? Or if it is under the refund policy, then there will be some guidelines will be given, no? What are those guidelines? Orders during shipment, orders during shipment qualify for refund. Okay, this is an example refund policy, correct? Now, this is the whole context, no? This is the whole context. Next thing is decide, no? Perceivable is done. What to do then? So the model perception of this reality is entirely determined by what? Information that it has given in the prompt, no? This is the prompt, probably. Think of it like, okay? Let's say if we are not given any of this information, let's say refund policy we have not given to the model. Can model decide, whether to refund or not? So perceivable, while perceivable itself, we need to give the proper information, a full context to the model. Correct? So here I would like to tell you, if you don't give the proper context to the model will be blind. One of the most common mistakes beginners will make is that thinking that agents fail because the model is weak. No. In practice, agents often fail because they never saw the information needed to make a good decision. Because the context. Information here that we are providing to agents is nothing but the context. If they don't see the right context, they can't take a good decision. So this whole thing is perceived, this context, right? If the context is proper, then perceivable is proper. The perceivable is proper, then decision will be taken properly. Okay. So perceivable is the prompt engineering problem. When I say, do you understand that? In the prompt engineering, in the prompt, we give the message. In that message, we put all this data. Customer has given this message. Customer has said that my order arrived damaged. Then the order status is delivered. Order value is $100. The refund policy is this one. Now the agent will take the decision because it got all the context. Okay. So out of three, yeah, I'll explain. Second one. The first one, what did we discuss? Context, right? What is it? Prompts. Prompts is very important thing. Prompts, where did we write this? Prompts, or I would say context. Prompt or context. Okay, this is very important thing. Now the second thing is tools. Now you are developing an AI agent. Humanly you can't it has to be automated, no? It has to be software, right? In the software someone has to provide this context to the model, isn't it? A human can't every time go and hit the database, get the information and put it into the prompt as a context, right? That is not a feasible thing, no? Okay, so that's where the tool comes into picture. Tools is, you can think of as functions. Since you are going to work in AI, you should be learning the Python, right? In the Python, you know the functions, no? Where you, write it with the def keyword and all, right? So tools, kind of like functions only. Okay. Now, let us understand tools. What is a model? LLM, like large language model. Basically, it takes the text as a input, right? And it gives the text as a output only, it can generate words. But what business wants? LLM handles with the text. What business wants? It wants action. So business wants action. So there is an LLM. Okay. There is a business. This can only take text. Business wants action. There is a bridge is required, no? That bridge is tools. Right? Tools is the bridge between this LLM model and business. So what is a tool? Tool is a simple function, simply a function that model requests. Remember, model will not execute the function. Model can only take text and give text only. But whereas the tool is a function that model requests. Who requests the tool? It's the model who requests based on the context given in the perceived stage. Then the tool is requested. It is the application. Our application is the one which will execute the tool. Okay. Examples: searching the database, searching DB. Tool will not do this. Okay. It is done by a tool, executed by application. Sorry, it's done by tool, not the model will not do this. Okay. Then read a file. As we discussed earlier, LLM does not have access to database. LLM does not have access to the file system. LLM does not have access to the email. Okay. Again, reading a file is a tool, is a function that can search a database, run a query, a function that can read a file. Again, it is run by application, requested by. These functions are requested by model. Okay. Requested by model, but executed by the application. Correct? Or anything like issue a refund, something. Okay. Now, if the tool, so tools are the bridge between the stateless LLM and business action. Correct? Imagine without the tools, agent is trapped inside a chat window only. No, either it's trapped inside a chat window, or whatever our AI agent is has to do. Basically, like it will receive the user's intent or the context or the perceival. It perceived, but it does not know the data how to access. Right? It wants someone to access the data and give the data to it. That's where it goes, and say that I need this tool. Okay. So with the tools, it can affect the outside world. Imagine our support agent decides it needs to verify an order, no? So what is the model will produce? Okay, verify the order. Perceival, right? It want to see what is the situation of the order, right? Then it will say in a JSON format, tool, lookup order, lookup underscore order. Okay. Then this is the function name, right? This is the Python function, right? Function needs some arguments, no? Then arguments, order ID. What did we say? 1, 2, 3, 4, 5. Let's say, or 4, 5, 2, 1, whatever is, right? Okay. This is what the tool will ask. Sorry, LLM ask. LLM ask for this. So verify order. LLM will identify this tool. That's what exactly it does. Model will identify given. I will tell you in part of the examples how does the LLM identifies, right? LLM identifies which for a given problem, which function, which tool needs to be called under, and it will put information in this particular order. Then this order is taken by application, no? Yeah. What app will do? It will execute, no? Execute lookup order, which will basically searches the database and it fetches the response. What could be the response? Status, delivered, payment, complete, value, $100, right? Something like that. This is the response. This response is what is given to the LLM. You see, LLM ask for tool app executes tool and give response back. You got it? Because model never actually runs the tool. Application does. Okay. Model only decides which tool should be called. Okay. Decides the tool call. Okay. So this is the second component. Tool is the second component. First component is context or the prompt. Okay. Now third component 3. What is this? Memory. Memory is for what? Agent to remember. No. Imagine you, let us say without logging to ChatGPT, we are typing something and we are asking, hey, give me this particular information and all. What kind of memory is it? Does the ChatGPT remembers this entirely? Tomorrow you will come, it will create a session today, you ask a question, it gave you the response, it will store for some time. That's a temporary memory. Short-term memory, I call it, right? Tomorrow or after 1 week, you come and ask the same question, it will not give the same answer. It does not know. Even it does not know that you asked this question. Because it did not know that you are the one who asked this question. No, there is no long-term memory it has created. Instead, you sign up, you sign in ChatGPT, you start asking the question. Whatever you do, it will save it. It will save it because the moment it saves it, it will become a long-term memory. After 1 week, you come and say that, okay, you click on that particular thread and say, hey, what is that we discussed? It will answer. Hey, this particular time, you have requested this one, and this is the answer I have given. So that is the long-term memory of a agent. Okay. The chart window that you are seeing ChatGPT, right? That behaves like an agent. That actually talks to the LLM like, ChatGPT, GPT, the 5.5, GPT-5, GPT-4 kind of thing. They were models. Okay. ChatGPT window itself is not a model. That acts like a agent. Okay. So short-term, long-term memory. Imagine that your agent is trying to do the fraud detection. Okay. It requires long-term memory. No. Basically, it needs to understand, card, which are the dates that card has been used, locations. Okay. And maybe the time and all, right? Like night time, daytime kind of thing and all these things are kind of like long term. No? Then only next time when another transaction comes, it will say, hey, the transaction is coming from UK, or otherwise the original card has been issued in India, Hyderabad. So maybe some kind of fraudulent activity could be happening, or maybe call is coming from somewhere from Nigeria or something like that, right? And then it will ask for the OTP. Hey, please confirm because this particular thing is happening. Or otherwise, you go to a big shop and making a big payment, let's say 1 lakh or 2 lakh rupees from a jewelry shop or something. Definitely, you would be getting a call, no? If you are using your card and all. That's where the fraud detection comes, no? Because it's a huge amount. Generally, you don't use that card like 5 lakh rupees you purchased. Generally, you don't use that card for 5 lakh rupees. Your spending activities hardly every time, maybe 5,000 max or 10,000 max. Suddenly, it has seen the huge amount. That's where it triggers. Okay. For it to understand, your regular spending and all or max amount, it needs to store the data. No? That is the long-term memory to take these calls and all. Okay. You understood? Short-term memory is a short-term session is created and you ask for a question, it has given the reply to you. It will forget after a day or so. Okay. And then now piecing all these things, no, um, 3 pieces work together. We put this right. So step one, pursue in case of a refund policy. In case of a refund case, first thing happened is pursue. In the pursue, what happens? What does the prompt contains? Email, order information, payment information, refund policy, correct? This is the prompt context that you have given to the LLM. And then step 2, decide case, right? In the decide case, model has reasoned out, okay? It needs more information, no? Right? It has gone to the, I mean, it asks for the tool to execute. The tool, let's say lookup order, maybe it require more information, okay? Whether the payment is not done or not, maybe, let's say in this context, the payment is not done. Okay, partial information is given. So now model wants additional information. For that additional information, it requested for a tool and it went to the lookup order. So application executes this lookup order and the response is given back to the model, correct? Isn't it? And the status becomes return, or if the damage is true or false kind of thing. Model has this refund policy, okay? The response become, let's say uh, damaged true, right? Now model will look into this refund policy and it will look into the damage true or not. Then it will decide yes, it can refund or not. Then it can make another call saying that okay, call this refund tool. Okay, this is the decide, right? Yeah, this is still observation only. This is still observation only. Step 1 only. Repeatedly it goes step 1. Now step 2, decide. Now it has all the context, full context it has. Once the full context is there, then it will make a decision. What is decision? Qualified for refund. Once it has taken the decision that qualified for refund, what is the next step? Act, perceive, decide, act, right? Act model will say again, tool, issue, refund. Correct? You understood? Now this particular function will process the refund. So these are the 3 steps that are completed. Perceive, trying to perceive the information, what is given to the model. If the model does not have the complete information, it requests for a tool for additional information. It identifies the tool which can give the additional information. Application will execute that tool and the response is given back to the model. Model thinks that if everything is fine, then it goes for the decision stage. If it's still not fine, again it will be in the loop. These are all in the loop, right? Again it will go into the loop and say it will find out another tool and say, okay, give me additional information. This time use this particular tool. Until it gets the complete information, it goes on calling for the tools in the perceive. Once the perceive is done, it will take a decision and all. Okay, even while taking the decision, if it requires some kind of additional information, still it can make a call to a function through a tool call. Okay. After that, it will take an action. While acting, again it will make a request for tool call issue refund. Then the application will make a issue refund call. Right. In this case, refund is processed. Then the confirmation is sent. Goal is achieved. Goal achieved, right? Look at how human has done. Look at how agent also has done. Almost they have done similarly, right? So the entire workflow, if you look at it, it's simply prompt, tool, memory. Okay. So these 3 are repeated inside perceive, decide, act loop. That's it. Your LangGraph, QA, everything is based upon these foundations only. So that is the reason. First, you need to understand how AI agent works. Then, when you go for the LangChain or LangGraph or QA, etc., and all, it's very easy for you to understand because you know the basics. Okay. Now, the next thing is that one of the insight, in AI agent engineering, the beginners sometimes, they obsess with the model choice. No, they say that okay, should I go for the GPT-4, Claude, Llama, Gemini? In production system, the biggest performance gains usually comes from improving the context quality. biggest performance gains comes from context quality, tool design, memory attitude, not from the models pickup and all. Even a mediocre model with the right context, right tool design, right memory retrieval, it can beat the state of the art model also. Okay. So agent engineering is less about finding a smarter brain and more about designing a better environment